Hello, the purpose of this video is just to show you another alternative for solving thermodynamics problems using software, and what I want to use is the website that wasn't able to call up the other day in class, and it is called thermofluids.net. And the first thing you need to do is either create an account, or if you've already done that, log in. The account is free, just requires your email address and a password, and then you can access all the features. So what we'll do is we're going to solve the last homework problem that we also did in class, which was problem 1.7, which was a steam turbine. And so we're going to go down to the bottom and pick Damon's. And here's the flow chart that shows the various types of problems that you may encounter in thermodynamics. And so what we're going to be looking at here is an open system that is steady state, and it has a single fluid, one inlet and one outlet. So I'm going to go ahead and select single flow. The material in here is steam, and so we're going to go ahead and use a phase change model, or a PC model. Then that's going to go ahead and open up this next window for. Okay, there we go. Took a minute. Okay, and here's our screen that shows all the various properties we're going to do. And one field, this front one, we're going to enter the inlets, and then we'll go ahead and enter the outlets on the next one. And so this is state 1. And in blue are all the thermodynamic intensive properties. In green are extensive properties, or extrinsic, meaning they depend on the observer, such as exergy would be one thing to think of. And then the extensive properties, like the mass flow rate. So let's just look at the problem. The inlet says an inlet of 2 megapascals, so I'm going to enter the pressure. So I'm going to click this and then enter the pressure in kilopascals. That's 2,000. It's also coming in at 350, so I'm going to select that and enter 350. I observe over on the right-hand side that I've selected a material of water. And the mass flow rate I'll enter down here as an extensive property at 10 kilograms per second. And now if I click the Calculate button, I see all these fields get filled in, so it goes ahead and looks up all of my intensive and extensive properties. So now let's enter the outlet. So I'm going to go ahead and advance to state 2. And now I know that what the outlet is a saturated vapor at 30 degrees Celsius. So I'm going to select the temperature and enter 30. And then it's a saturated vapor, which means I'm going to enter the quality at the outlet of 1. And then the mass flow rate, I could enter 10 here again, or I can do simply equal to m.1, where it'll go ahead and retrieve the value from the previous screen. Now I go ahead and click Calculate, and it goes ahead and calculates all my intensive variables. So now what we need to do is solve the problem where it wants to know the heat rate. So I'm going to select the Device Panel tab up on the top, and here it shows me the three balances it's going to solve: the mass balance, the energy balance, and an entropy balance for me. But first I need to tell it what the inlets and outlets are. So I've got device A. It's the only device in my system. My inlet state is going to select that as state 1. Oops. State 1, and then my exit state as state 2. Now the problem says this produces 5,000 kilowatts, so I'm going to select 5,000 and enter that value, and then I'm going to go ahead and click Calculate. And there I see the heat flow rate at 806 kilowatts. It's minus, because according to the picture here, this is the heat input, so it's minus, which means there's 806 kilowatts leaving. And that's how easy it is to solve the problem. I never had to go ahead and look at the property tables.